Hi, everyone. Welcome to another episode of the Student Spotlight series, where we showcase some of the work our past students have done. Today, it is our pleasure to have with us Sophia Smith. So, Sophia, can you tell us a bit about yourself, where you're from, what school you're in, and what course you've taken with CCIR?
Right. I'm from Pittsburgh, Pennsylvania. I've just finished my junior year of high school. And I go to a little uh, private high school in the area called Our Lady of the Sacred Heart High School. Um, and I was a part of the CCIR one-on-one mentorship program um, with a focus in medicine, medical research, biology.
So, how did you find out about the program or become interested in taking a program like this?
Um, well, I've known for a couple of years that I'm interested in research, and I did a couple of programs before this, and I was looking for more with my mom, more opportunities, and I was especially interested in finding a more personalized experience that wasn't in a class setting because that was something I hadn't seen before. And it was actually my mom who stumbled across CCIR first.
So, can you say a bit about how the program was structured? I mean, so what was your project, and I guess how did you approach it?
Right. So I know that the one-on-one mentorship looks different for everyone, and that's one of the big advantages. Um, for mine, um, my mentor spent the first couple of weeks teaching me how to conduct the kind of research that I was going to be doing, so how to use the particular tools that I used, and just covering some, some basic, information about the field, not, yeah. And then after that, I got to start working on my own research problem. And yeah, so the bulk of the program was spent doing the research and then writing the paper.
So, what was the topic of your paper?
So I looked at three carbapenemase genes that were found in P. aeruginosa and looked at the prevalence of those genes and their associated proteins in other species. And I focused especially on the implications of my findings for cystic fibrosis patients who often have chronic infections by opportunistic pathogens such as P. aeruginosa.
So was this something that you came into the program with like a pre-existing interest in, or is this a topic that you kind of settled on with help from your mentor?
Well, coming into the program, I knew that I was very interested in the problem of antibiotic resistance, and I knew that I had an interest in genetics and infectious disease. I love infectious disease. Um, But it was my mentor who first suggested P. aeruginosa as a focus for me. So that was really the first time that I studied that particular pathogen in depth.
So can you say a bit about how your project fits into the existing literature, I guess in the field? So what did you read to prepare to, do your research? And I guess how are you contributing to the existing research on the topic?
Well, to prepare for my own research, I read a lot of reviews that just kind of evaluated sort of the status of the escape pathogens, which include P. aeruginosa, and papers on cystic fibrosis specifically and how those infections usually work. Um, And I looked into some of the other work that people have been doing recently using the same tools that I ended up using. So more of this genomic sequencing, this genetics-based approach. Um, and then my little contribution was, well, again, taking a genomic approach to see how these genes um, work not just in P. aeruginosa, but outside in other species. So my goal was sort of to try and get some attention to other species who have these genes and express these proteins that aren't studied so much right now, and to find where our knowledge gaps are in which species have developed which kinds of resistance and which genes have these particular proteins. Because although like genome sequencing and protein sequencing isn't new, there's still a lot of empirical research that we haven't done. So again, one of the goals was just finding those gaps where we might want to have some researchers sequence the genomes of these other pathogens to see what the dangers are there.
So I'm a complete layman when it comes to this subject. So I wonder if you could help me understand, like in very simple terms, what's at stake here. I remember earlier you mentioned something called an escape pathogen. Maybe we could start there. What does that? I guess what does that mean? What's the significance of that?
Yeah, so the escape pathogens, I won't list them all, but there are a couple of specific species that are really clinically relevant right now that have become extensively resistant to drugs. And P. aeruginosa is one of them. So obviously I've like came in with an interest in these pathogens. And yeah, basically they're just very difficult to treat. And they also are common agents of infection. So it's kind of it's a very bad combination. They're common and they're becoming more dangerous. So that's that's basically that's basically what's at stake, right? We're trying to um, find the weaknesses um, and learn more about the strengths of these pathogens, which are becoming the most problematic in clinical settings.
Okay, I think I'm following much more clearly now. So then
Yeah,
basically for your project, you were sequencing the genomes of antibiotic resistant pathogens. Am I on track?
sort of. So obviously I didn't like go into a lab and sequence the genomes myself, but I took the already um, empirically researched sequenced genomes from these banks. And then I used the information I found there to extrapolate new data. So basically, the information was there, but I had to determine what it meant and what we still don't know.
Okay, so can you say a little bit more about what the method was there and then maybe what the key insights or takeaways were at the end?
Right. So there were a couple different tools that I used, and I started with a tool called BLAST. Um, and what you can do is you can put in the sequence of a gene or a protein, and you can get a list of species that have genes and proteins that are similar to the one that you put in. So basically, what you learn from that is what other species have these genes and have these proteins. And so BLAST has a couple different modes. You can do it for nucleotide sequences or protein sequences, and you can have it like translate a nucleotide sequence into a protein sequence and see what species would have that. And you can have it translate an amino acid sequence back to a nucleotide sequence and see what species would have that. So it took a long time, but for all three of the genes that I was studying, I went through BLAST and combed through the results and saw which species had um, had similar sequences to the ones that I was studying. And then from there, you get to a couple of different protein-based tools. So there's the worldwide protein um, database, yep, WWPDB. And what you do there is you can put in a protein sequence and you can see the protein that has been empirically, that's empirical data that was found in a lab. Um, and then if a protein's not available on WWPDB, you can predict its structure using an AI tool called AlphaFold. There's a site called Interpro where you can um, that kind of like BLAST shows you a bunch of different species that have homologies to the protein that you put in, but it's more protein focused. Um, so yeah, just taking all of that data together, um, you can see what species truly have a similar, uh, well, for which species the protein is really similar to the one that I was looking at P. aeruginosa, and you can see species that have a protein that may or may not serve the same function as the one that you found in P. aeruginosa. So, yeah.
So if you were going to continue doing this research, or I guess working in this field, what would the next steps be, or what would the eventual application of the research you've done be?
Well, one of the biggest applications would be um, predicting um, which for which species carbapenems wouldn't be a wise choice for a treatment plan. So if you know that a species is resistant to a certain drug, you're not going to want to administer that drug because A, it's not going to treat the infection because the bacteria are resistant, and B, it's actually going to exacerbate resistance because it's going to continue to breed out those susceptible bacteria. Um, so you know for which species carbapenems maybe aren't the best choice. And if I were to continue the research, another thing that I would look at um, are some of these surprising results that I found while I was looking on Interpro. There were some species listed there um, from Eukaryota and Archaea that weren't on BLAST. So there were species that weren't bacteria, that were animals or fungi um, that have these genes, and it's not clear, or that have the proteins, and it's not clear why these species would need these proteins because they're not trying to become resistant to antibiotics. So it's unclear what they're using them for. So um, it would be really interesting to look into how they get those genes or proteins and why and what they use them for.
Yeah, that sounds extremely fascinating. So is there any research on that topic, or was this just a totally unexpected discovery on your part?
Um, well, I haven't really looked into it yet. I'd love to comb the literature to see if somebody else has, well, I'm sure somebody else has found something like this, but I'd love to read about how other people have handled it. Um, but in preparation for my own work, in my literature preparation, I didn't see anything about it, so I was pretty surprised.
Yeah, that sounds extremely interesting. Were there any other sort of surprising results that you found, or anything about the process that was surprising for you?
Oh, there were a lot of things. Well, this is another thing that I well, I brought this up in my paper, but um, there were some species that were bacteria. So this is apart from the Eukaryota and Archaea results, but there were some species listed that aren't super well known to be extensively resistant to drugs, and yet um, had um, maybe 2 out of 3 of these genes or 2 out of 3 of the proteins. Um, and some of them, while most of them were pathogenic, at least opportunistic pathogens, yeah, a lot of them weren't super famous or common. So I guess it's similar to the issue of the Eukaryota and Archaea, but um, I was just wondering, how these particular bacteria came to have so many of these genes and proteins that code for carbapenem resistance when um, you wouldn't expect them to have been placed in an environment where that would have become especially desirable. So I'm not sure if that's going to become a clinical issue or if it's just like an interesting anomaly for now. But yeah,
So you mentioned that you brought this up in your paper. Have you finished your paper?
basically, a lot of the work in the past couple of days has just been formatting. Yeah, I'm basically done. I'm gonna fix up a conclusion, but other than that, yeah.
Can you say a little bit about how your mentor has supported you through the paper writing process? I mean, was it more collaborative, or was there a lot of kind of independent work?
Well, I had a lot of autonomy, more than I was expecting, to be honest. And I felt a little bit at first that I didn't know what I was doing, which wasn't totally untrue. I had just learned to use many of these tools and techniques. Um, but it was ultimately really freeing and helpful to me to get that autonomy from my mentor, because it taught me how to solve problems and think for myself. And also taught me how to do research in my own style. So the autonomy was great. Um, but at the same time, my mentor my mentor was extremely supportive without being overbearing. He looked over everything that I wrote. He would bring up, well, counter arguments, I'd call them, although you can't really argue with results, but he'd bring up things to think about, and help me sort of formulate my responses. Yeah, I don't know how to describe it really well, but it was just an excellent balance of autonomy and support from my mentor. He was great.
Yeah, that sounds like, well, I mean, that's basically what I was going to say. It sounds like a good balance. It sounds like you had, I guess, the autonomy you needed to grow, but also help available as
Mm.
well. You needed it. So do you feel like the program has prepared you well to continue doing research in the future?
Yes. I knew before I applied for CCIR that research was what I wanted to do, but now I'm even more sure of that. Um, yeah, and I've been reaching out to um, other programs and other people in my area for opportunities, because I feel prepared to take them on now. CCIR was a big step for me. This paper was a big step for me. I learned to use a lot of tools and methods um, that I was totally unfamiliar with before. Yeah, and I really enjoyed it, and I'm really happy with what I got out of it and what I learned and what I did. So
Yeah, that's great. I mean, I think research is it's a difficult skill to learn. And I feel like, I guess getting acquainted with it early is just a huge advantage. So I'm glad to hear that. Do you have any advice that you would give someone coming into the program? Or maybe advice that you would have given yourself if you had the opportunity?
yeah, I know I hear this a lot, and it probably will sound a little bit trite, but since finishing CCIR, I think it's worth repeating. Like it's okay to not know what you're doing and to make mistakes. It's pretty inevitable. And I don't even mean like objective mistakes or factual mistakes, or you used a tool wrong, um, or you got the wrong data. I mean like you're not I I don't think someone doing research for first time should expect to know how to do it in the way that works for them. And so I know that I um made a lot of, well, maybe mistakes isn't the right word, but I wasn't I did things in the way that wasn't the most efficient, or the best for me, just because I didn't know yet what was best for me, because this was one of my first, real experiences with research. So I had to fumble around and I had to figure out how to do things the hard way. Um, but I think that's the best way to learn, because now I do know what works for me. And when I do research, I bring my own, unique personal approach to it. So it's difficult at first, but I think it's the best way to learn. So it's okay to not know what you're doing.
Yeah, I think that's great advice. I mean, it definitely is something that you hear a lot, that it's okay to make mistakes and that in a way putting yourself out there and being courageous, is a key component of learning. But at the same time, I think it's like, I guess I feel like there's a lot of advice that gets repeated over and over because it's very hard to take it to heart. And
Yeah.
sometimes the only way to really, uh, well, yeah, really take the advice to heart is to experience it. I realize I should have asked this earlier, but are you planning to submit your paper to any journals or conferences?
I'm hoping. I mean, I'll ask my mentor for advice about that, of course, and CCIR will help me along in that process. But I definitely would like to, have it out there somewhere or get to present it in public. It'd be great.
Yeah, I definitely hope that you get the opportunity to do that. And it sounds like you have plenty of support for finding, I guess, avenues for making that happen. So do you have any final remarks that you'd like to make about your experience or anything else you'd like to share?
Uh, Well, I can't really think of anything specific, but it was a great program for me, and I really loved it. And for anybody who's considering but unsure, I would definitely encourage them to apply and to try it out. Um, it's really unlike anything I've ever seen or done before, and I learned so much, and it's left me really excited. I know that CCIR is an academic program. Of course, it's marketed as an academic program, but they also mentioned on the website and during the application process the importance of passion and enthusiasm in research, and I think um, CCIR has definitely amplified that in me. I would have considered myself enthusiastic about my subject when I applied and when I started, but um, now I'm even more curious and I have more questions and I have more confidence that I'll be able to um, pursue the opportunity to explore my questions through research in the future. So CCR is great program and everyone should do it.
That's great. I mean, that sounds like an ideal outcome. I really feel like, I mean, especially doing academic research, which maybe you might not necessarily, that might not necessarily be your primary interest, but I mean, doing research in general can be at times not very rewarding, or at least the reward is very, very delayed. So I feel like passion is so essential. You have to find a way to enjoy the process. And I think that's like the best, that's one of the best things that you can get from doing a project, learning to enjoy that process more. Uh, so yeah, I'm glad that you had such a positive experience, and I really appreciate you taking the time to share about it with us.
Yeah, thank you for having me.